Essay 5.10 Integral Rules. With today's video, we will discuss a little bit more about integration. So section A, let's first talk about the basic integrals. So on top of our first rule of the integration, following are the four rules that we can also use for some other basic functions. And these four rules are actually included in your formula booklet. So you don't have to memorize it. However, let's discuss a little bit more about the case where we have to use the Euler's number or the case where Euler's number is actually part of the integration. So when you look at this case here that is written in this box, e to the power of x times dx case, this is very simple. This is the simplest form of the integration that you can do. However, there's also a case where the Euler's number actually has a power of ax plus b times dx. In this case, what's happening is we take that number a, or the number that goes with the power, the x part of the power, to the front. So we move it to the front. So it becomes 1 over a times e to the power of ax plus b plus c. Okay, and also there can be a case where we actually have a number in front of Euler's number like this and dx. In that case, what we need to do is, let's make just d. Okay, in that case, what we need to do is we still take the 1 over a to the front, but multiply with the d, and then keep the power as same, and write that the mystery c. Okay, then let's try the example number 1. So we need to find the we need to integrate 4x cubed plus 1 over x times dx, right? So this is one of the simplest rules. So what you can do is we can integrate the 4x cubed first. So we do 4 times x to the power of 3. We add 1 to the power and divide the term by the new power, right? And for the 1 over x, we know that when we integrate 1 over x, it becomes the natural log x, right? That's part of the rules that you need to memorize. So it becomes the natural log x plus c. So we have 4 over 4 times x to the power of 4 plus natural log x plus c, and which simplifies into x to the power of 4 plus natural log x plus c. Then let's do number 2, example number 2. So we have dy over dx equals 5 times sine x. We need to find the y. So we have a derivative of the function y, right? Dy over dx is same as y prime, and we all know that. And what we're going to do is we want to integrate this y prime, or derivative of the y, so we can find that original function. Okay, so when we integrate this 5 times sine x, it becomes 5 stays same, right? Because it's constant. And then sine x, according to the formula, we know that it becomes cosine x, negative cosine x. So negative cosine x plus c. And we know that this is y, original function y. So it's y equals minus 5 times cosine x plus c. Okay, then let's talk a little bit more about the integration rules. Okay, so here we have ax plus b rules, means this is the rule that we can use to integrate the cases where we use the chain rule to differentiate. Means we use the ax plus b rule to integrate the functions that actually that are in the form of the composite function. Okay, so when you look at this case, this means we need to differentiate the sine 5x plus 2, right? So you can, it is very clear that you can clearly see that this is a function inside a function. So the outer function is sine x, right? And then your inside function is 5x plus 2. So means we need to use the chain rule to solve this. So when you use the chain rule, this becomes, we need to first have to differentiate the outer function. So the outer sine part becomes the cosine, right? And then we have cosine 5x plus 2. And after that, we take the inside and we differentiate that inside part. So it becomes the 5, right? Then our differentiated form of this function, this composite function, is 5 times cosine 5x plus 2. Then let's look at the second one. So when you look at the second one, q part is your outer function, right? And then inside part is 6x minus 7. So this is inside. The cube part is your outside. So we first have to differentiate the outer part. So it becomes 3 times 6x minus 7 to power of 3 minus 1 times we take the inside and differentiate, and this becomes 6, right? Then we get the final equation of 18 minus 6x minus 7 to power of 2. Okay, so this was how you differentiate the cases with the chain rule, right? Then let's try to talk about how to integrate these cases, okay, that uses the chain rule to differentiate. So to integrate the cases that uses the chain rule, we need to use the integration rule called the ax plus b rule. In your formula, it is listed in this way, okay? So when we differentiate this, what we need to do is we take the inside function and we take the constant or the coefficient that goes with the x variable and then put that into the fraction form at the end. That's what we need to do ultimately. So let's try to use the one of the example. So we have f of x equals to 6x minus 7 to power of 3, right? So when you differentiate this, it becomes f prime x equals to 18 times 6x minus 7 to power of 2. And if we want to integrate this back to f of x, what we need to do is we first integrate this function using this concept or this formula. So means it becomes 18 times 6x minus 7 to power of 2 plus 1 divided by 2 plus 1. So we use the basic integration formula to integrate it first. After that, we multiply the coefficient of the x inside the function. We take the coefficient of the x of the inside function and then put that into the fraction form and then multiply into that integrated form. So it means we take 6 and put that into the fraction form, so 1 over 6, and multiply into the remaining part, okay? Then we have that c, the extra constant, right? Then this gets simplified into 18 times 6x minus 7 to the power of 3 over 3 times 1 over 6 plus c. So it gets simplified into 6x minus 7 to the power of 3. Okay, and c, or we already know that there's no c. However, since we can just put it as a 6x minus 7 to the power of 3. Okay, then let's try the example 3. So we like to integrate the 10 times cosine 5x plus 3, right? So what we need to do is, we know that already this is the function there's an outer function and then inside function, right? So this is the composite function case, function inside of function. So what you need to do is we first differentiate, or we first integrate the outer function. So the cosine becomes the sine function, right? So sine 5x plus 3. After that, you take inside and put that, take the 5 and put that into the fraction form like this. After that, you simplify, so 10 over 5 times sine 5x plus 3. So it becomes 2 times sine 5x plus c plus c. Yeah, so that's your integrated form of the function, this function, example number 3. Then let's try the example number 4. You can see that this is the Euler's numbers case, right? So what we need to do is we're going to use the case where we have to do Euler's number to the power of ax plus b, or times dx equals 1 over a times e to the power of ax plus b plus c. Okay, we're going to use this formula. Then we can do 16 times e to the power of 5 minus 4x over negative 4, because we take the negative 4 and put that into the fraction form, right? So the answer is minus 4 times e to the power of 5 minus 4x plus c. Okay, then let's try to do one more example, okay, using the Euler's number. So let's say we have, we need to integrate the 25 times e to the power of 5x plus 1 times dx. To integrate this, we're still going to use this formula here. So we're going to do 25 times e to the power of 5x plus 1, and we take the coefficient in front of the x variable and then put that into the fraction form. Okay, then we get 5 times e to the power of 5x plus 1 plus c. Okay, if I do, or let's do another example. We need to this time integrate the negative 1 over 4 times e to the power of 4x plus 2 times dx. So in this case, same thing. We're going to put that into e to the power x plus 2, right? Then we're going to multiply the fraction that has a coefficient as the coefficient of the x as a denominator. So it becomes, we multiply the 1 over 4. So it becomes negative 1 over 16 times e to the power of 4x plus 2 plus c. Okay. So now we have done a reverse chain rule for integration, right? So the next integration formula, or the rule that we're going to go over, is called the substitution rule. So we use substitution rule to make things easier, okay? Because sometimes in the examination session, like if the question is really complicated, then it takes up a lot of time. Then it's really, it does not give, so it is, so when question is complicated during the examination sessions, it is quite challenging for us, for like, you know, in terms of time consuming and everything, right? So what we want to do with the substitution rule is we want to simplify the function before actually we do integration with it. Okay, so we can do integration in much easier way. So this is the rule that we can use with the substitution. But what you need to remember is you can only use substitution when you have function multiplied with another function, and that another function needs to have a function inside it, then you can use a substitution rule. Okay, so you can use substitution when function multiplied with other function and then the other function has a function inside it. So let's do example number 5 right away. Okay, so when you look at example number 5, you see a function multiplied with the other function, and that other function has the function inside it, right? Then we can use a substitution rule with this case. And as I told you before, if you see radicals or the fraction with the derivative or integration, then you need to make it into non-fraction and non-radical format to make the function or the process much easier. Okay, so we have x cubed times square root x to the power 4 plus 1 times dx. And we definitely don't want the radicals within the process. So when we do the process, so we're going to change that radical to a power format. So x to the power 4 plus 1 to power of 1 over 2, right? And times dx. So now you're going to set the inside function, right? The inside function x to the power 4 plus 1 as u, okay? And that means our equation becomes integration x cubed times u to power 1 over 2 times dx, okay? So we're going to change everything in terms of u. So we need to differentiate the u. So it's going to be du over dx equals to 4 times x cubed, okay? And we know that we need to get rid of the x cubed and the dx because we want to change the function in terms of u. So let's try to rearrange this in terms of the u, okay? So du is equal to 4 times x cubed times dx, right? That means 1 over 4 times du is also equals to x cubed times dx. That means x cubed times dx can be replaced with 1 over 4 times du. So x cubed times dx going to get replaced with 1 over 4 times du. So we get integration u to the power 1 over 2 times 1 over 4 times du. Then we can integrate this using the power rule, 1 over 4 times u to the power 1 over 2 plus 1 over 1 over 2 plus 1 plus c. So we get 1 over 4 times u to the power of 3 over 2 over 3 over 2 plus c. So this is equals to 2 over 12 times u to the power 3 over 2 plus c. So this becomes 1 over 6 times u to the power of 3 over 2 plus c. And since we know the u is x to the power 4 plus 1, we can replace the u with x to the power 4 plus 1 to the power of 3 over 2 and plus c. And that's your function. Then let's try the practice IB question. So this is the IB question from specimen paper. So we have f derivative equals to 8x over square root 2x squared plus 1. And given that f of 0 is equal to 5, we need to find the original function. So we need to integrate this f prime. And you can see that this has a fraction and radical in it, right? So we're going to get rid of the fraction and then radical form, okay? So this becomes f prime of x becomes 8x times square root 2x squared plus 1 to the power of negative 1. Then we know that 8x times 2x squared plus 1 to the power of negative 1 over 2, right? So we can now change the fraction and the radical to non-radical non-fraction form. And let's try to integrate this in terms of the x. So it's a dx. And you can see that this is the function multiplied with the function, and that other function has the function inside. That means we can use the substitution rule. Okay, so we're going to set u equals 2x squared plus 1. Then du over dx is same as 4 times x. Then since we want to change everything in terms of u, let's change the format of this into 4 times x times dx. Then we can say integration 2x squared plus 1 is u, so u to the power of negative 1 over 2 times 8x times dx. This is same as u to the power of negative 1 over 2 times 2 times 4 times x times dx. So 4x times dx can be replaced with du, right? Then we get integration u to the power of negative 1 over 2 times d times du. So when we integrate this function here, this becomes 2 times u to the power of negative 1 over 2 plus 1 over negative 1 over 2 plus 1 plus c. Then when we simplify this function, it becomes 4 times u to the power of 1 over 2, or let's include one more step. This is same as 2 times u to the power of 1 over 2 over 1 over 2 plus c. And when you simplify 2 over 1 over 2, this becomes 4 times u to the power of 1 over 2 plus c. And we know that u is same as 2x squared plus 1. So we can substitute that into equation. So we know that f of x is equal to 4 times 2x squared plus 1 to the power of 1 over 2 plus c. And we also know that when x value is equal to 0, y value is 5. So we can substitute 0 into our equation. And this becomes this. And we can solve for the c. So means when you simplify everything, it becomes 4 times 1 to the power of 1 over 2 plus c equals 5. So c value is equal to 1. So our final equation is 4 times 2x squared plus 1 to the power of 1 over 2 plus 1.